Alright, in this problem we have a car that starts off with an initial velocity. It's moving at a rate of 45 meters per second. It accelerates for some period of time, and there's a car covering some displacement, a delta x of 264 meters. What is the rate of acceleration? So we'll define the kinematic formula as displacement is equal to v naught t plus 1/2 a t squared. And this is a little bit complicated because the a, which we're solving for, is buried deep in this cavern of variables. It's multiplied by t squared divided by 2, and this entire term, 1/2 a t squared, has v naught t multiplied by it. So the first thing we'll do is to subtract v naught t from both sides. So we end up with delta x minus v naught times t is equal to 1/2 a t squared. So now we have to continue working our way through isolating a. A is divided by 2. So let's take and put this entire side in parentheses. So I'm going to multiply by 2 on both sides. That will cancel the 2, and then divide by t squared, which will cancel it on this side as well. I'll rewrite acceleration is 2 times displacement minus v naught t, which carries dimensions of meters, the whole thing divided by t squared. So just let's quickly address the units. Delta x is meters minus what velocity is, meters per second, times seconds. So that will give us meters minus meters, which are meters, the whole thing divided by seconds squared. So we have meters per second squared, and it works out rather well. So now that we've showed that the units work, we'll just get rid of that, and we can go back and sub in our values, and that's going to be 2 times the displacement, 264 meters, minus the initial speed, 45 meters per second, times the time, 4.8 seconds, the whole thing divided by the square of the time, 4.8 seconds, quantity squared. Alright, now that the numbers are subbed in, we can reveal the answer, which is going to be a little bit complicated. Let's go back and fix one thing. We just did not put a parentheses, which will be helpful in terms of order of operation. So if we do 45 times 8, subtract that from 64, multiply by 2, divide the whole thing by 4.8, we will, it's complicated, come up with an answer of 4.17 meters per second squared. So we'll just reveal the entire slide so we can see the entire substitution, that it's accurate and similar, 4 meters per second squared. Definitely acceleration occurs.